And welcome back, students. We are now going to talk about the ATX motherboard. Because remember last time we talked about motherboards, but now we're going to delve into a little bit more specifics. So, getting started. As mentioned, we have discussed motherboards and their role in computing. This lesson we shall be looking at one specific type, the ATX. Now, ATX, which stands for Advanced Technology Extended, is a motherboard configuration specification developed by Intel all the way back in 1995. It was the first major change in desktop computer enclosure, motherboard, and power supply design in many years, improving standardization and interchangeability of parts. Now there exist four members of the ATX family. There's the regular ATX, you have micro ATX, mini ATX, and flex ATX. Now there's also extended ATX, but it's pretty much the same thing, it's just a larger board. Alright, let's talk about that ATX. Now ATX is currently the most common motherboard design. There are standards that exist for smaller boards, such as like micro ATX and stuff like that, which usually keep the same basic rear layout, but reduce the size of the board and the number of expansion slots. Dimensions of a full-size ATX boards are typically 12 by 9.6 inches. The official ATX specifications were released by Intel in 1995 and have been revised numerous times since. One of the most recent ATX motherboard specifications is 2.2, though there exist other ones like 2.31 for power. The general specification for the components and stuff hasn't changed that much. All right, let's talk a little bit about some variations and improvements since we are talking about that. Here's the extended ATX, which I kind of alluded to previously. It's simply just a bigger version of the ATX motherboard with a 12 by 13 inch dimension. Remember, the regular ATX is 12 by 9.6. This is 12 by 13, so it's a little bigger. One of the big advantages of having an ATX motherboard is support for dual Xeon CPUs. And in 2004, Intel announced the BTX, or Balanced Technology Extended Standard, which is intended as a replacement for the ATX. However, as of 2017, the ATX design still remains pretty popular, while BTX has been introduced by some manufacturers. You know, you can get like micro ATX too now, but it's not as popular as ATX because that's the form that most people are familiar with. All right, we're going to start delving a little bit into some connectors, so we're slowly starting to dig our way into the different pieces of the motherboard. We're going to start sinking our teeth in just a little bit. ATX allows each motherboard manufacturer to put ports in a rectangular area on the back of the system with an arrangement they could define themselves. Though a number of general patterns, depending on what ports the motherboard offers, have been followed by most manufacturers. Cases are usually fitted with a snap-out panel, known as an I/O plate or an I/O shield. I/O, of course, meaning input-output, in one of the common arrangements. So there's several different ones that they typically follow. If necessary, I/O plates can be replaced to suit a motherboard that's being fitted. The I/O plates are usually included with motherboards and aren't necessarily designed for a particular computer. Because usually they'll just have a slot on the tower that would go for that plate to sit in. Now, believe it or not, the computer will operate correctly without a I/O plate fitted. Like, it's not going to not function if your I/O plate's missing. Although there will be some open gaps in the case, because also you're missing a whole piece of aluminum, and the EFI RFI screening will be compromised because now you have this open area there for electromagnetic frequency to come through. Now, some ATX boards also come with an integrated I/O plate, which means that rather than it being a other piece of metal that you attach, it's integrated right into the board, so you cannot remove it. All right, talking still about connectors, ATX has also made the PS2 style mini DIN keyboard and mouse connectors kind of ubiquitous, which means that they're one and the same. However, many modern keyboards are in the process of phasing this completely out. So PS2 keyboard connectors, while they're great if you don't have the USB drivers, many computers aren't having them anymore in favor of the more universal serial bus USB. The only downside of that is if you don't have the USB driver, you don't have a PS2 connector, and you have a driver issue, you could run into issues. Now, other legacy connectors that are slowly being phased out of modern ATX boards include the 25-pin parallel ports and 9-pin RS-232 serial ports. Those things are just slowly disappearing. In their place are onboard peripheral ports such as Ethernet, FireWire, eSATA, audio ports, both analog and SPDIF, video, which includes analog D-sub, DVI, HDMI, or DisplayPort, extra USB ports, and Wi-Fi. Yes, some ATX boards have built onboard Wi-Fi. All right, let's talk a little bit about some variants. Now, several ATX-derived designs have been specified that use the same power supply, mountings, and basic back panel arrangement, but set different standards for the size of the board and the number of expansion slots. Standard ATX provides standard 7 slots at 0.8-inch spacing. A number of manufacturers have added 1, 2, or 3 additional expansion slots at the standard spacing to the standard 12-inch motherboard width. And of course, we need to talk about power because the motherboard is the primary consumer, unless you have a GPU. Originally, the motherboard was powered by one 24-pin connector. So you would have this 24-pin connector that would come from your power supply, and it would plug into your motherboard to supply energy. An ATX power supply provides a number of peripheral power connectors, and in modern systems, 2 connectors for the motherboard. You have the 8-pin auxiliary connector providing additional power to the CPU because the CPU needs its own energy, and a main 24-pin power supply connector. So obviously you don't have just one 24-pin connector. Now you have at least 2 mandatory connections. An ATX power supply is typically controlled by an electronic switch connected to the power button on the computer case and allows the computer to be turned off by the operating system. In addition, many ATX supplies have an equivalent function manual switch on the back that also ensures no power is being sent to the computers. So it's kind of like a kill switch. So rather than just the front panel button or going through software to shut everything down, there's a physical button on the back of the power supply that if you flick that will kill the power to everything. When the switch on the power supply is turned off, however, the computer cannot be turned on with the front power button. So the front power button is reliant on that back switch being thrown to the opposition. All right, one last thing to talk about in regards to the motherboards here. There's these 4 wires for special functions. The first one is PS on or power on. This is a signal from the motherboard to the power supply. So this is a tiny little wire that gets plugged into your motherboard. So what this does is when the line is connected to the ground by the motherboard, the power supply turns on. It is internally pulled up to a +5 volt inside the power supply. So this little wire right here is what helps control the power on. Power OK or power good is an output from the power supply that indicates that the output has stabilized and is ready for use. So this is kind of like a state test wire here. And what it does is it remains low for a brief period of time, which is 100 to 500 milliseconds, after the PS on signal is pulled low. So first goes PS on, then it checks power OK. Next, you have your +5 VSB or +5 volt standby. This supplies power even when the rest of the supply wire lines are off. This is typically used to power the circuitry that controls things like your power on signal. So even though, as long as the computer is plugged in and receiving news, this is what's going to tell the rest of the computer, hey, there's a signal being sent that you need to check to turn yourself on. Then you have the +3 volt sense, which should be connected to the +3 volt on the motherboard or its power connector. What this connection does is allows remote sensing of the voltage drop in power supply wiring. So this is what actually kind of acts as the sensor. Some manufacturers have also provided, though, a +5 volt set wire, which is typically colored pink, connected to one of the red +5 volt wires in some models of the power supply. However, the inclusion of such a wire is a non-standard practice and was never part of any official standard for ATX. And that concludes our notes, folks. Until next time.